Alright, in the diagram you see here, I'm briefly going to talk about standing wave patterns, how they form, and then what they actually are. So here on the left-hand side we have an oscillator that oscillates at a specific frequency f. Doesn't matter really what the frequency is. However, it sends down these pulses, okay, at a regular rate. So these pulses travel down, okay, and then they hit this point here. This is a fixed end, essentially. The end doesn't move. Same goes with this. This is also a fixed end because both of them are tied down in some way or another, okay, to each end. Now, as this pulse travels down, it's going to reflect back. So the front of this will reflect back, and since it's a fixed end, it'll reflect back inverted, and the bottom, or the top, would then reflect back on the bottom. So it's going to travel back as it goes like this. Now, as this oscillates at a regular rate, the waves being sent out are going to interfere with the waves coming back. Now, when a standing wave pattern occurs, the frequency is just right so that the wavelength of the Lang interferes perfectly at the crest and constructively interferes perfectly at the crest and destructively interferes perfectly at the equilibrium point. So the subsequent pattern that we get is as follows. Alright, to the right here, I'm going to draw this pattern here. So the blue line represents a string going out. Now with the strobe light, and before I left for break, I showed you guys that this is really only one string. So the solid line goes out, alright, and then it's reflected and it's inverted, and it's at perfect frequencies, it's going to interfere at very specific points. So the green line only represents what we appear to see as that other part of the loop. Alright, so, just to get a couple things of terminology here. This little section we can call one loop. Okay, it appears to be a loop, but it's really not. It's just since it's oscillating so quick, it reflects over itself, and it's difficult to see that there's only one string, so it appears to be one loop. Alright, now a couple other important things here with this representation. If we look through and see how far one cycle actually is, if I start at the equilibrium point and go through one cycle would look as follows. Start here, come up and over, come all the way back down, back to the equilibrium point. So one complete cycle in this picture is going to turn out to be the distance from equilibrium point as it goes all the way up to the crest, goes back through the equilibrium point all the way down to the trough, and back to the equilibrium point. This would be considered one cycle, and the length of that would be considered one wavelength. So in this case, two loops would equal one wavelength. So essentially you're going one hole up and down. Now, the string itself has a length, and that's related to this distance L. So we can look at this and say, alright, well, if I know that two loops are equal to one wavelength, and the length of this string is L, we can combine these things and talk about how the length of the string, in this case, is going to be one whole cycle and a half. So this would be 3/2 of the wavelength. Alright, and that's what this standing wave pattern actually represents. A couple notes on terminology here. We talk about two different things. We talk about nodes and antinodes. Nodes are places of complete destructive interference. In other words, that in the picture, essentially the blue the blue waves traveling out will reflect and interfere with the green coming back. At the points where there are nodes, there's total destructive interference. So the string doesn't vibrate at all, or vibrates very, very little. And then the antinodes, the places in between, are points of total constructive interference. Here's where the medium vibrating constructively interferes and creates large amplitudes, and this is what appears as a loop. Alright, these places are known as antinodes. They're along here. You have large constructive interference in both the positive and the negative amplitude. Alright, so nodes and antinodes, things to keep in mind. Terminology to keep in mind as we go through this unit.